All right, so section 5.5, we have direct and inverse variation. There's two types of variations that exist in this world. Well, actually, there's three. There's joint as well, but most people just deal with direct and inverse variation. Now, direct variation basically is when one thing occurs, and let's say that one thing makes something go upward, so like you make more money, right? So then you spend more money, right? That's called a direct variation. So when you make more money, you can spend more money, right? Or if you eat too much, you can gain weight, right? Something that goes up makes something else go up. Or it can also be something going down. So if you spend more money, so that means something's going downwards, right? Then your bank account starts to go down as well. So something else goes down. So direct variation basically means if something goes up, the other thing goes up as well. Okay? Or if it goes down, the other thing goes down as well. So the act of one thing directly affects the action of the other thing. Okay, so up goes up or down goes down. Okay, both are going to go up, both are going to go down. So the reason why I tell you that is because when you guys are doing these problems, I want you guys to make sure that when you check your work, see if it kind of makes sense. Like if you're solving for one and you notice like it went up, up, and your answer went up, down, that doesn't make sense. They should both be going higher and higher or lower and lower. But I'll show you how to check that as we do some examples. So direct variation, here is the definition for it, okay? So normally, well, not normally, but sometimes you'll see this statement in the very beginning. It'll say, if x varies directly, maybe I should spell that right, directly as y, then, so if x varies directly as y, meaning like x and y are directly related, so they're going to have direct variation, okay? Then we get k equal to y over x, where k is the constant of proportionality. Now I'm going to try to show this to you guys in the easiest way possible. Okay, there's two ways I can show it to you guys. One way requires you to solve for k and then plug it into another equation. Okay, that's one way. The other way is to create a proportion, like a fraction equal to a fraction. And that's actually the easiest way. Okay, so I'm going to show it to you guys the easiest way possible. So we're not going to solve for the constant of proportionality, but maybe I'll show you one little example near the end of how that looks if you were to do it the other way. Okay, but the way I'm going to show you today is actually the easiest way to do it, so it's not hopefully going to take you too long. All right. So again, if x varies directly as y, now they might say that, maybe they won't. They might just say, well, these are direct variations. Like your homework, it's going to literally say direct variation on the top, so you know they're directly related. Okay. But they might say if x varies directly as y, so that means direct variation, then k is equal to y over x. Make sure you guys memorize that, okay? Inverse also has its own formula, also very small. It's not a big formula, so make sure you memorize that one as well. So they say k is the constant of proportionality. So here we go. Some examples on how you're supposed to do these things, okay? So here we go. Example number 1. Now, all of these you're going to have to write out. I'm going to have to write out. So this first one's going to be a little bit on the easier side. It says, if x varies directly as y and x equals 2 when y equals to 10, find x if y is equal to 30. So if x varies directly as y, okay, and x equals 2 and when y equals to 10, then find x if y equals to 30. Yes, we will. Yeah, we're going to set a proportion of it. Mm-hmm. Yeah. So, so right here, first off, notice the very first part of this sentence says if x varies directly as y. So they are telling you that this is direct variation. Okay. So I'm kind of just going to highlight it there. So this basically tells you, okay, you're going to use a specific formula. Okay, k equal to y over x. All right. But like I said, we're going to try to write it out as something a little quicker. So what I'm going to do right now is on the side, I'm just going to write this formula out, okay? Just so that we remember this is the formula we're using. K equal to y over x. So now, the next part gives me information to put into that fraction. It says if x varies directly as y and x equals 2 when y equals 10. X equals 2 when y equals 10. So if I were to plug that into that right side equation, I would write 10 over 2, correct? Y is 10 and x is 2, right? So this is what I'm going to do. I'm going to get my first fraction, y over x, okay, and I'm going to set it equal to y over x. This is what I'm going to do. Because I got to create two of them. Okay, how do I know I got to do two of them? Well, because in the very beginning, they give me x equals 2 when y equals 10. They gave me information for that, 10 over 2. And then when I keep reading the problem, it says find x if y is 30. So that means I could put a 30 here and an x there. Okay, so each portion of the sentence is going to give you a little piece to that problem. Okay, so the first part gave me the first fraction, 10 over 2. And the second part of that sentence gave me the second fraction, which was 30 over x. Are we okay with that? Where I found the information to put in? Now, proportions is something you guys have done since Algebra 1. All you do is you cross multiply. Now, you might want to reduce 10 over 2. It's up to you. You don't have to. But if you don't want to, that's okay. We're going to basically multiply like this. I would recommend reducing it, but if you don't want to, let's just show what it looks like if you don't. So 10 times x is 10x, and 2 times 30, that's 60. So if I divide both sides by 10, what do I get? 6. And that's my answer. Okay? Now, does that make sense that x is 6? Well, let's see. X used to be 10 when x used to be 2 when y was 10. Now that y is 30, which means it's bigger, x should also be bigger then, right? If y got bigger, x should get bigger. And notice my x went from 2 to 6. So that makes sense. Okay? The inverse variation is backwards. If one gets bigger, the other gets smaller. Okay? So this makes sense to me. X used to be 2 when y was 10. Now that y is 30, x got bigger. It became 6. Okay? Couldn't you just multiply across by 3? With inverse variation, it won't work. With direct variation, it can work. Yeah, so in case, for those of you guys in the recording, watching the recording, the question was, can I just multiply 3 times 10 and 3 times 2? It does work at times. For inverse variation, the formula is a little different, so it doesn't work the same. So that's the reason why we don't teach it like that, because sometimes people will adapt that way of doing the work with inverse variation, and then they get everything wrong on the inverses. So, but yeah, with direct, they are directly related, so you can just kind of quickly do it. Now, I made it so that these numbers kind of matched up nicely. So that's why maybe the multiplication by 3 would work really nice. But now let me show you what the problems are going to look like in your homework, okay? So this is like kind of like the broken down way of doing it with not too much information. Now let me give you a couple other ones. All right, so this is going to be example number 2. So they are all going to be word problems, okay? So Trailblazers Incorporated is known for making high quality suits. So Trailblazers Incorporated is known for making high quality suits. Now sometimes the intro sentence has nothing to do with the problem, okay? Now we know these are direct variation because it's going to title it direct variation at the very top of your worksheet, okay, in the front. So that's how you know you're going to do direct variation. If they take 9 days to stitch 90 suits, how long will it take them to stitch, to complete an order of 180 suits? So again, these numbers are kind of nice right now, so sometimes just doing a quick multiplication would be easy. But some of the problems here, like I know the second one I'm going to show you guys, is not that simple. So if the numbers are nice, you can kind of do it quickly. So this is a suit company. They make suits. If it takes them 9 days to stitch 90, how long will it take them to complete 180? What would you say? If you just think of it as multiplication? 18 days, right? So let's just double check it. Okay, let's double check to see if 18 days is correct. Y over x is equal to y over x. This means that you're going to have to assign something as x and something as y. I always tell people just whatever comes first, call it x, and then the next thing will be y. So the number of days, I'm going to call it x. And the suits, I'm going to call y. And then I'm going to keep reading the problem, and I notice it says, how long will it take to complete an order of 180 suits? That's also y. Right? Suits are y, days are x. Now you can flip it if you want. You can make the suits be x and the days be y, whatever you want. It doesn't matter. Just be consistent. Okay? So let me start filling it in. 9 days for 90 suits. So 90 over 9 equals 2. And then the other one says 180 suits, but I don't know how many days, and that's the thing I'm trying to figure out, right? How many days does it take to do 180? So again, I would recommend you reduce this, okay? Like for example, 90 over 9, that becomes 10, right? This is 10 equal to 180 over x. So all I'm going to do, by the way, that's 10 over 1. All I'm going to do is cross multiply. So that gives me 10x equal to 180. And if I divide both sides by 10, I get exactly what was stated earlier, 18 days. All right, so again, if the numbers work out nicely, an easy multiplication is what you can do just in your head really quick, right? With direct variation, that works. Not with inverse, okay? Because inverse is more of a fraction. It could be a little different. But with direct, it can work. Now I'm going to give you one more example like this, another word problem, where the numbers don't work out so nicely. So you are going to have to use your formula. Okay? But anybody have any questions on this one? Again, if they don't give you the x and the y, you're going to have to assign them. Okay? You assign the x and the y. All right, so let's see. Example number 3. By the way, you only have 10 problems on your homework. The first one we did is not a homework problem, but the one we just did and this next one right now are homework problems. So a popular hair salon disbursed daily wages of $641.88 equally among 8 shampooers. Determine the number of shampooers that were employed at the salon. Determine the number of shampooers that were in the salon the following day. If the salon paid out a total of $1,152.90 as daily wages. I'm going to go ahead and pause right now just to let you guys write this stuff out. All right, so again, I'm going to write y over x equal to y over x. All right, that's my direct variation. Okay, now it says popular hair salon dispersed daily wages of $641.88 equally among 8 shampooers. So let's just call it x and y. Okay, the money is your x, the shampooers is your y. Determine the number of shampooers that were in the that were in the salon the following day. So I got to solve for y, right? Because they want me to figure out the number of shampooers. If the salon paid out a total of, so here's the money, x, right? So let me go ahead and plug everything in. I have 641.88 divided by 8 equal to, they want me to know the number of shampooers. That's y. I don't know the number of shampooers, but they did pay $1,152.90. Okay, so I'm just going to cross multiply because I don't want to reduce any of that. I'm sure I could probably do it, but yeah, because 64 and 18 and 8 work just fine. But let's just use our calculators, okay? So 641.88 times $1,152.90 comes out to this big total here, 740,023. I'm just going to round it to the nearest tenth because that's how we do money, right? So 45 cents equal to 8y because 8 times y. Now I'm going to get that total and I'm going to divide it by 8 so I can solve for y. Okay, so oh yeah, no, I did do that right. No, I didn't do that right. I just realized something. I flipped it. The first one I flipped it. I apologize, guys. I just realized the first one I flipped it. Y is 8. X is 641.88. Sorry about that. Y is 8. I noticed right now when I was doing the work how my money was diagonal. I'm like, no, they should be either both on the top or both on the bottom. Isn't that what I... Well, earlier I put y equals 8, but it was backwards. I had flipped my fraction by accident. I put the x on the top and the y on the bottom, where it should have been the y on top, the x on the bottom. So I fixed it right now. It should look like that. Sorry about that. Give you a little bit of time to fix that. Notice how my money is both on the bottom, right? That makes sense because they're directly related, so they should both be either both on the bottom or both on the top. All right, now let me do the multiplication. 1,152 and 90 cents times 8. That's going to give me 9223.20. 9223.20, and that's equal to 641.88. Y. That looks a lot better. Now I'm going to divide that by 641.88. Okay, 641.88. And this is what I get. So 14.37 is equal to Y. Now, what does Y represent? It's people, right? Can I have 14.37 people? So then how many were there? So who earns the rest of the 0.37? No? You got to pay to somebody. So don't undercut the people. Count them up. Round up. So there's actually 15 people that had to share that. Because if you stop at 14, that 0.37 of the money doesn't just go back to the company. No, they have to pay it out. So who gets it? It has to be another person, right? So there's going to be approximately or 15 shampooers that are going to have to share this. Because trust me, if you're a company and you have extra money and you have like 0.7 left over and you're like, I'll just keep it. Yeah, get ready to get sued. It's going to be like, no, that's our money. What do you mean you get to keep it? Right? Give us all a 37th of that money. All of us should earn that 37, right? You don't want to get cheated by the company that you work for. So yeah, that money has to go to somebody. So you round up for people, for items, for living things. You round up. Okay. So always ask yourself, like, does 14.37 people make sense? Maybe not. Right. So, all right. The next one is inverse variation, and I'm only going to do 2 of these. Okay, I'm not going to do 6 examples because they're pretty much the same thing. The formula is different, but the idea is identical. Okay, you're going to get word problems. You're going to have to use those word problems to solve. All right. So inverse variation, and you might like this one because this one the formula is xy equals to xy. Okay. So here we go. Inverse variation. Now this is the one where I could say, like, the more you drive, the less gas you have. The more money you spend, the less you have in the bank account, right? The more you rest, the more energy, the less time you have to do stuff, right? Like, so they're inversely related. One goes up while the other goes down. Okay. Normally, you might see if x varies inversely as y. Sometimes when it's not a big old word problem, they might just write that down. Then k is equal to xy. Again, k is the constant of proportionality, so it's just not going to change. I'm not going to rewrite it. K is just the constant of proportionality, right? Now, when we solve these problems, instead of y over x equal to y over x, we're going to use xy equal to xy, okay? So here we go. First example. So I'll put it right here. Example number 4. So again, we just got 2 more. So this one and another one. So if x varies inversely as y and x equals 12 when y equals 8, find y when x equals 5. So if x varies inversely as y, and x equals 12 when y equals 8. Find y when x equals 5. Now, quick question. Should y be bigger than 8 or smaller than 8? Smaller? X got smaller, so y should actually be bigger. Inverse variation means when one goes up, the other goes down. Or when one goes down, the other goes up. It's inversely related, right? If it was directly related, then yes, x got smaller, therefore y should get smaller. Okay? But with inverse variation, if x gets smaller, y should get bigger. Okay? So I know that, so I better get an answer that's bigger than 8. It could be a little bit bigger, it can be a lot bigger, but as long as it's bigger. So here we go. xy equals to xy. I know my x and y's already. They say x is 12 and y is 8, so let me put 12 times 8 is equal to, they say find y when x is 5, so 5y. Now, 12 times 8, that's going to be 96, so 96 is equal to 5y. And if I divide both sides by 5, that does not go in evenly, so let's see what we get. 19.2. Does that make sense that y is bigger than 8 in this case? X got smaller, y got bigger. Okay? Inversely related. So I'm just going to kind of highlight that. So again, those are kind of little clues that when you're doing this work, you're like, oh, that makes sense. So I think I trust my work. Like my number got bigger when the other one got smaller, right? So pay attention to that. Now one more of these, but this one's going to be one of the word problems, and then we're done, and then I'll give you guys a homework, like I said. So let me write this one out for you guys. So the example number 5, our last one. An airplane travels at a speed of 582 miles per hour. An airplane travels at a speed of 582 miles per hour to reach its destination in 4 hours. All right, so that's definitely, they're not going to Hawaii. Hawaii takes 5 to 6. Unless you got an amazing tailwind, then maybe. Determine the duration of the flight if the airplane travels at a speed of 388 miles per hour. So determine the duration of the flight if the airplane travels at a speed of 388 miles per hour. So again, I'm just going to basically assign x and y to whatever I want. It doesn't matter. Well, actually, no, it does matter. You can do it wrong. But for the most part, people don't mess this up. Okay? Read the problem from the beginning, and then as you see numbers popping up, give it x and give it y, right? So here we go. Airplane travels at a speed of 582 miles per hour. So I'm going to let speed be x, okay, to reach its destination in 4 hours. So I'll let time be y. They say determine the duration of the flight. That means I got to find y if the airplane is traveling at the speed of 388. So they gave me x, right? So speed is x, time is y. I got to solve for time. So again, my formula is xy equal to xy. So the first one, x and y, are 582 and 4. So 582 times 4 equals 2. And then the next one, determine the duration of the flight if the speed is 388. So 388 times y. So I'm just going to get my calculator. and do some calculations here. 582 times 4 is 2328. And then to solve for y, I'm just going to divide both sides by 388. So let me divide by 388. And the answer comes out to a nice number, 6. So it will take 6 hours. I think, not that you have to write down the problems, because you're not going to have to do that. But if you did have to write them down, it would take you longer to write down the problems, I think, than to do the work. Okay? The work is not terribly difficult. Assign your variables right over the problems. Put x, y, right? Use the right formula. Again, xy equal to xy is for inverse variation. Y over x equal to y over x is for direct variation. Okay? Use the right formulas. You should pretty much be okay. Use a calculator in case you need it. All right? So I'm going to stop right now and give you guys your homework.